Hey guys, I hope everyone's doing well. I just wanted to make you a quick video because some of the things that you're going to be doing today are review. You've done them before for 7th grade, but some of the things are new. And so just hang in there with me. We're going to talk about some equations that have no solution and some that have an infinite number of solutions. So just a review of the word term in math, that just simply means that terms are either a number like 12, a variable by itself like x, a product of a variable and a number like 2x, or it could be the quotient of a number and a variable like c over 3. Those are all individual terms. And how do we identify each term in a long expression? Well, terms are separated. I can't change my screen. Terms are separated by addition signs or subtraction signs. So the first term is a positive 3a, then I see a subtraction sign. That subtraction sign actually belongs to that second term. So actually that would be considered a negative 2/5 x, but since we have a minus sign or a negative sign, that tells us that this is a separate term. The next term is a positive 7x. The next term is a negative 4z or minus 4z, and the last term is 52. So how many terms do you see? We have 5 individual terms. Just another reminder, the word constant in math means it's a number not attached to a variable, right? So like in the first slide we saw, the number 12 is a constant. It's not attached to a variable. But if you have a number attached to the variable, like if it was 12x, excuse my grandmother's clock, then that number in the front is the coefficient. So that it says a coefficient is the number value in front of a variable in a term. So the whole thing is a term, 12x. The variable is x and the coefficient is 12. Up here, the 12 is just considered a constant because it's not attached to a variable. So in this example, what are your coefficients? Well, we have 2 numbers attached to variables, right? A 3 and a negative 6. And that means the number not attached to a variable is our constant, which is the number 18. So we're going to start solving one-step equations. And that means that you only have to do one mathematical operation to it. So the 4 operations in math are addition, subtraction, multiplication, and division. And so when you only have to do one of those operations is considered a one-step equation. All right, so when you're solving equations, it's like having a old-fashioned scale. Whatever you do to one side of the scale, you have to do to the other side of the scale to keep that scale balanced. All right, so that's basically what this is saying. So when you're solving equations, the first thing you want to ask yourself is, what is the variable? And even a better question would be, where is the variable? On which side of the equal sign is the variable? The second thing, what operation is being performed to the variable or on the variable? So 3x means the x is being multiplied by 3, right? And the last question is, what is the opposite operation? Or what's the inverse operation of multiplying? Or what's the opposite of dividing, which will be multiplication? What is the opposite of subtraction? Addition, right? So that's how you solve equations, by completing the opposite operation, also called the inverse operation. All right, so let's look at some. Just these first few are a review of things you've already done. So here we have x on the left side of the equal sign. So we want to get rid of that plus 4. What's the opposite of plus 4? We're going to subtract 4 from both sides of the equal sign to keep that scale balanced. So 4 minus 4 is 0. We got rid of it. We bring down x. So 12 minus 4 is 8. And then with all equations, you can always check your answer. If x is 8, does 8 plus 4 equal 12? Is that true? Well, sure. All right, what about the next one? What is being done to our variable y? Well, y is being, from it is being subtracted 7. So we're going to do the opposite. We're going to add 7. And so I got rid of this section. So I bring down my y. So 13 plus 7 is 20. And then if I double check my answer, does 20 minus 7 equal 13? Why, yes, it does. All right, here we have 6 is being multiplied by a. So we're going to do the opposite of multiplying by 6, which is dividing by 6. And 12 divided by 6 is 2. These cancel. 6 divided by 6 is 1, and 1 times a is just a. And the fourth one, b is being divided by 2. B divided by 2 is 10. What's the opposite of divided by 2? Well, that would be times 2. So this is just like this problem, and you can cross simplify, right? So all we'd have left is b over 1. B divided by 1 is b, and 10 times 2 is 20. And to double check it, you would say, is 20 divided by 2 10? Is that true? Yes, it is. All right, so some of our problems that you're going to solve today have an infinite number of solutions. For example, first thing, hopefully you notice, is that you have a y on both sides of the equal sign. Well, when you have variables on both sides of the equal sign, you want to get those variables together. So that means you're either going to cancel out this y on this side or this y on this side of the equal sign. So how do you get rid of a positive y? You would subtract y. Okay, the reason we would do this is to get our y's together. Well, y minus y, just like 5 minus 5 is 0, y minus y is 0. And it just so happens that this one on the right side would cancel out also. So if we try to get our y's together, basically we would cancel them. So our statement left over is -4 equals -4. Well, is that true? Yes, that's true. That is a true statement. So if you end up having no variables and you end up with a true statement, that means that you have an infinite number of solutions. Infinite solutions, number of solutions. Oh my goodness, pay attention. All right, so for example, if I said y equals 3, if I plugged in 3 right here, 3 minus 4 is -1. Well, if I plug 3 here, 3 minus 4 is -1. So -1 is -1, that's true. Or what if I put 10 for y? I would end up getting 6 equals 6. So no matter what number I substitute for y, I would get a true statement. That's why this has an infinite number of solutions. All right, let's look at this one. All right, so the first thing I'm going to do on both sides of the equal sign is I'm going to combine like terms. So these are not like terms, so we got to leave it like this. Well, isn't 5 minus 2 positive 3? 5 plus 2 is 3, so I'm combining like terms. Well, once again, just like when we started here, do you see that these are equivalent? This expression is exactly the same as this expression. Well, now that I've simplified this, I noticed that these two expressions are exactly the same. So I could go ahead and try to get my 2a's together, or I could try to get my 3's together and say, okay, well, I'm going to get my 3's together by subtracting this 3. Well, what happens is it cancels out both of them, and I get a true statement. I could have marked out the 2a's, and I would have got 3 minus 3 equals 3, which is true. So basically, if you ever get to a place where you have the exact same equation, or excuse me, expression, equivalent to the same expression, that means you're going to have an infinite number of solutions. I hope that makes sense. All right, let's look at this one. Now, sometimes you will find that there is never going to be a solution. Your equation will never be equal to each other on both sides of the equal sign. For example, if I ended up saying, okay, well, I have variables on both sides, so I'm going to get those variables together. So I'm going to get rid of this positive 2a by subtracting 2a. Well, guess what happens again? 2a minus 2a is nothing, and 2a minus 2a is nothing, right? So what happens? My variables disappeared, and I ended up with 3 equals 0. If someone owed you $3 and said, here's $0, it's the same thing, would you say, that's okay? No, you'd say, forget that. $0 is not equal to $3. That is not true. No, so that means there is no solution. There is no number I could substitute for a and make this equation true. All right, let's look at a different one. What about this one? Well, 5x is equal to 5x, that's true, but on this side it says -7, right? So what if I say, okay, well, let me try to get my 5x's on the same side of the equal sign? Well, once again, I'm ended up gonna get rid of both of them. 5x minus 5x is nothing, and nothing minus 7 is -7. Is that true? No. If it's not true, you're going to end up with no solutions. So do you see what happens? On one side, we had just 5x, and the other side, we had 5x, but then there was something added to it. That extra part is going to make those two sides never equal. I hope you understand. Just like this one. 2a and 2a, those are equal, but then they threw +3 only on one side. If they threw it on both sides, we'd have an infinite number of solutions. All right, so I want you guys, there are 12 problems here, right? I want you guys to pause the video and I want you to try all 12 of these, and then I want you to check your answers. You're basically solving them, and you're answering this question. Does each equation have one solution, an infinite number of solutions, or no solutions? I'm getting a phone call, so I'm pausing my video. All right, so on the first one, since we can solve for x by dividing by 5, or z, I don't know my letters, you guys. So 5 divided by 5 is 1, and 1 times z is z. So -20 divided by 5 is -4. So obviously that's one solution. And the one solution is z equals -4. Don't forget your integer rules. A negative divided by a positive is a negative. All right, number 2, if I tried to divide both sides by 6, I would end up getting y equals y, but I don't even have to do that, because when I notice they are exactly equal to each other, I don't really need to go any further. I know that there is an infinite number of solutions, infinite solutions. All right, number 3, always attempt to get x by itself, or whatever variable it is. So this type of problem tricks people. I'm not trying to trick you. I'm just showing you that you got to be careful. Here we have x on the right side. So what's the opposite of +4? Well, that would be -4, correct? So what happens? 4 minus 4 is 0. So I'll bring down my x. But guys, -4 combined with -4 is not 0. If I owe George $4 and Sarah $4, how much debt am I in? I'm in debt -$8. So in your calculator, if you typed -4 minus 4, it will tell you the answer is -8. It's not 0. So there is one solution, and that solution is x equals -8. I hope you got it right. All right, number 4. So I'm looking, now I'm thinking, are these the same thing? Could I rewrite this and make it equal a plus 5? Well, they're both positive numbers, right? So if I turned this around, that is still a true statement. And now I can see for sure that these are exactly the same expression. And so that means I have an infinite number of solutions, infinite solutions. Number 3, if I try to get my x's together, if I wanted to try to say, okay, let me get rid of this -x by adding x. Well, what happens is both of these cancel, and I would end up with 3 equals 0, which is not true. Or I could just look at it and say, well, since I have variables on both sides, if it just said -x equals -x, I would know that would be infinite solutions. But they added that little extra part right there, which tells me that these are not equal. These two things are not equal, so there's no solution. Now, the reason this is not the same as number 5 is because on number 5, there's variables on both sides. On number 3, there isn't, right? This doesn't say x minus 4 equals x plus 4. That's not what it says. All right. So anyway, look at number 6. So here we have variables on both sides. And what do you notice about this? They're almost the same, but they're not the same. So if I ended up saying, all right, let me get rid of one of the numbers, I can get rid of the 5. That would be x. 4 minus 5 is -1. Well, if I added 1, I could just, this is never going to work out. If I tried to subtract an x from both sides, I'd end up with 0 equals -1. So basically, since I can see that these both have variables, but they're different expressions, this has no solution. All right, how you guys doing out there? All right, what about these 6? Have you tried these? So number 1, I only have one variable I see. So how do I get rid of times 2? I'm going to divide both sides by 2. So 2 divided by 2 is 1. So 1 times x is x, and I would get 29, I believe. Okay. Number 2, 2a plus 7, and then I have 2 constants over here, which I can add those like terms, right? Can I add 5 plus 2? What is 5 plus 2? 7. So 2a plus 7, oh, okay. So now I see what's going on. What do you notice? Those are exactly the same. So we have infinite solutions, infinite number of solutions for number 2. Number 3, I have one variable. It's being multiplied by -2. So I'm going to do the opposite of multiplying by -2, which is dividing by -2. -2 divided by -2 is +1. And 1 times a is a. And 10 divided by -2 is -5. -5. All right, number 4, I have x's on both sides. Since those are the same variable, I'm looking at the rest of it. Do these match? Nope. So if I subtracted 3x from both sides, I'd end up with -5 is equal to 8, which is not true. Or hopefully I could just look right here and say that is not true. These variables are the same, but the constants are different. So there's no solution. All right, what about number 5? I noticed that these match exactly. Since they match exactly, I have an infinite number of solutions. And look at number 6. Does 5 equal 10? Is that ever true? No, that's not true. So the answer is no solution. All right, guys, I hope that you did those and got those right. And tomorrow we will Zoom. Tomorrow is Thursday, so join me again. And tomorrow we'll start doing same type of problems with two-step equations. So you guys have a great day, and I will see you tomorrow.